online classes for Ncert and Cbse 10th standard for mathematics and science. So in the previous session of quadratic equations, we had discussed regarding the nature of the roots, which depends upon the discriminant value of the quadratic equation. So here discriminant is defined by b square minus, that is 4ac. b square minus 4ac is called the discriminant, which discriminates what type of roots are to be given for the respective quadratic equations. So among them, we classified the nature of the roots to be of 4 types, right? First one, if the discriminant value is equal to 0, then the nature of the roots will be real and equal. So how many real roots are there in this case?
1.
2 roots or 2 real numbers or 1 real number?
1.
Right, exactly. So if discriminant value is equal to 0, then the roots are real and equal, and only 1 real number will be the root, because both the roots are equal, therefore we consider only 1 real root, right? So these type of questions will be particularly asked in your multiple choice questions for 1 mark. You have to be very careful, right? So if discriminant value is greater than 0, and along with that if it is a perfect square, then the roots of the given quadratic equation are
Real and
rational. So in this case, how many real roots are there? 2. Because both the roots are separate, both the roots are real, and they are equal and distinct. Distinct in the sense?
equal.
That's a different root. This is a different root. So they are not equal in the sense, right? They are distinct. So right. Okay. Third one. If the discriminant value is greater, if it is greater than 0 and not a perfect square, then what is the nature of the roots?
Real and irrational.
So if the discriminant value is greater than 0 and not a perfect square, then the roots of that particular equation will be real and irrational. So can you tell me how many real roots will be there? 2 or 1? 2 real roots. So that is different. This root is different. So that means they are distinct, right? And the last one, very important. If the discriminant value is less than 0, how many real roots will be there? No real roots. So what type of numbers you are going to get as roots? Complex or
imaginary.
Right? So these were the things which were discussed with examples in the previous session. I hope if you have not seen that previous session, please stop this video here, go back to the previous session, watch the session once again and come back to this video so that you will be able to understand today's session, right? So in today's session we will be going with very simple problems on quadratic equations, where we discuss more about the nature of the roots of the quadratic equation. So very simple, 1 mark questions we are solving here once again. Find the nature of roots of quadratic equation. Just a quadratic equation will be given to you. You have to take the quadratic equation and find out just the nature. Just tell us the nature of the quadratic equation, that's all. So don't find out the quadratic equation if they are real or something. In yesterday's session we did some problems on that. No need, just find out the nature of the roots of quadratic equation, right? Right. Can any student tell me one quadratic equation?
2x square
Yes.
minus
2x square
minus 5x
minus 5x
minus
1
is equals to.
Alright, fine. 2x square minus 5x minus 1 is equal to 0. So she has given me a quadratic equation which is already in the standard form. It's already in the standard form. So no need to bring it to the standard form. But in order to write the discriminant, that is b square minus 4ac, we need the values of a, b and c. So where we have to extract it from the given quadratic equation by comparing with the standard form, right? So first we will compare the given quadratic equation with the standard form and extract the coefficients, and then we will find out the discriminant. Depending upon the value of the discriminant, we will decide the nature of the roots. Done? Right. 2x square minus 5x minus 1 is equal to 0. So comparing with ax square plus bx plus c is equal to 0. That is the standard form. So here a value is
2.
a. Coefficient of x square is a, Here coefficient of x square is 2, so a is equal to 2. That's all. You have to compare. Right? So how to compare? By looking. That is, you have to look properly, you have to look carefully. That's very important. Right? Okay. So a is equal to 2. Then b is equal to
minus 5.
right, exactly. B is equal to minus 5. C is equal to
Minus 1.
right, okay. So we have the values of A, B and C. Now let us write the discriminant. So discriminant is given by so according to your textbook they have used the D, the letter D. So in the previous year's textbooks they were using delta symbol. So things are left to you. Whichever you want to use, you can use it. So D is equal to B square minus
4ac.
right. So D is equal to B square
Minus 5 whole square.
So B square is minus 5 whole square minus 4 into A
2.
into C.
Minus 1.
Exactly. So D is equal to minus 5 whole square
25.
minus into minus.
Plus.
Right. 4 2s are 8, 8 1s are 8.
8.
So D is equal to 25 plus 8.
33.
33. Okay. So D is 33. So at this moment we have to think. Right. So what is 33? 33 is an integer greater than 0. But
Not a perfect square.
not a perfect square. Right? 36 is a perfect square. 25 is a perfect square. So this number is in between 25 and 36. So it is not a perfect square. So according to the things what we had learned in the previous class, if the discriminant value is greater than 0 and not a perfect square, what will be the nature of the roots of the quadratic equation?
Real and irrational.
Real and
Irrational.
exactly. Right. So since D is greater than 0 and not a perfect square, so therefore roots are real, distinct and rational or irrational?
Irrational.
Exactly. So and irrational. Right. So this is how you have to calculate. Okay. So this question can be asked in the reverse order also. If a particular quadratic equation has roots which are real, distinct and irrational, then what may be the value of the discriminant? The value of the discriminant may be not 33. May be greater than 0 and not a
Perfect square.
right? Okay, let us get into the second problem. Right, yeah.
3x square
3x square
minus 2x
minus 2x
plus 1 by 3
plus 1 by 3.
is equal to
Right. So it's already in the standard form. So you are all looking at the term 1 by 3, I know it. Because your entire quadratic equation is looking very peculiar here. Because in the denominators, that is C value is 1 by 3. So usually when you get these type of quadratic equations, usually what do? You take the LCM for by 1 and 1, 1 and 3 you are going to take LCM, or very simple, you are going to multiply the entire equation, that is on both LHS and RHS by 3 to eliminate 3 from the denominator. You can do it. But if you maintain it in the same manner by taking C is equal to 1 by 3 in the data, no problem, you can get into that. Right? If you want to convert it, no problem. Very simple, multiply by 3 on both sides, that's all. If not, if you are not interested in that, please go with the same manner. Right. So comparing with ax square plus bx plus c is equal to 0. So coefficients are, okay, a is equal to
3.
ax square represents 3x square, x square, this is x square and a is 3. So a is equal to 3. Then b is equal to minus 2. C is equal to
1 by 3.
yes. Okay, no problem, you can take it. So now discriminant is given by, right, d is equal to b square minus
4ac.
4ac. So d is equal to b square
Minus 2 whole square.
minus 2 whole square minus 4 into a
3.
into c
1
by 3.
1 by 3. Okay, so d is equal to minus 2 whole square is
4.
minus 2 into minus 2. Minus into minus.
Plus.
See, something like this. Many get confused here. Minus 2 whole square can be written as minus 2 into minus 2. So minus into minus is
Plus.
2 is
4.
That's all. When I tell you what is minus 2 whole square, these steps should run in your mind. Right? Okay. So it is 4 minus 4 into 3 into 1 by 3. Right. So easily you can cancel 3 and 3. Done? Right. So d is equal to 4 minus 4. So d is equal to 0. Oh, fantastic. You have got the value of d as 0. So discriminant value you have got it as 0. So according to the conclusions, nature of the roots, right? If the discriminant value is equal to 0, then we say that the roots are
Real and
real and
equal.
please don't use the word distinct. Distinct doesn't apply here, right? Because both are same, both the roots are same, right? So since d is equal to 0, discriminant value is 0, so therefore roots are real and equal, right? So I will with this, in this problem I will take an opportunity to give you a note regarding this, right? So find the nature of the roots of the quadratic equation and also find the roots if it is asked, according to the yesterday's question, if it is asked. And in this scenario, if you get d is equal to 0, if you get discriminant value equal to 0, we know that roots are equal. So in order to find those equal roots, we use the formula. So instead of b square, that is inside the root b square minus 4ac, instead of that we are going to use d. Instead of d we are going to use 0. So apart from doing those things, I will give you a simple shortcut, right? Very simple. So we know that roots are given by x is equal to minus b plus or minus square root of b square minus 4ac by 2a, right? So please take it as a note. Take it as a note, and this note can also be asked in your examination for 1 mark. So x is equal to minus b plus or minus, this entire thing b square minus 4ac can be written as discriminant by 2a, that is this entire thing represents d. B square minus 4 is the discriminant. Discriminant is represented by the letter d. Okay. So x is equal to minus b plus or minus, what is the value of discriminant you have got?
0.
0. So let us substitute square root of 0 by 2a. Okay. So x is equal to minus b plus or minus 0 by 2a. So x is equal to minus b by minus b plus 0 by 2a, or x is equal to minus b minus 0 by 2a. So x is equal to minus b plus 0 is minus b by 2a. This is one of the root. Or x is equal to minus b minus 0 is again minus b by 2a. So this is the standard form of equal roots, or the general form of equal roots. So if for a quadratic equation, if discriminant value equals 0, then the roots are equal. Those two roots generally they look like minus b by 2a and minus b by 2a. This is what happens, right? So here minus b by 2a, they will ask you in the quadratic equation ax square plus bx plus c is equal to 0. If discriminant is equal to 0, then the roots are option A. They will give you this minus b by 2a minus b by 2a, or represented by, or in the form of, right? You have to remember. So equal roots of a quadratic equations, general form will be minus b by 2a and minus b by 2a. So now he has asked you here, for example, until here we did the problem and we concluded here. Roots are real and equal. if they ask you to find the roots, then you can use that general form. Easily you can use it. So I'll find it out here. So x is equal to minus b by 2a. You can take any one. One is enough. Don't take 2 times, because as I told you, if roots are equal, there is only one real number. Only one real number. Okay. So x is equal to, what is the value of b?
Minus
Here we already have minus. Minus of minus 2 by 2a. That is 2 into.
3.
Okay. So x is equal to minus into minus 2 is
2.
2 by 2 3s are 6.
Six.
2 1s are 2 3s are. So x is equal to.
1 by 3.
So which are those equal roots?
1 by 3.
1 by 3. So you take this quadratic equation, do the factorization method, and you can check out whether you are getting these equal roots or not. Don't believe me, do it. Sir, I will check. What you are telling me, I am taking the information, but I don't believe that all the information what you are giving is, I don't believe it. I am going to check it. Please check it. Take this quadratic equation by the method of factorization, do it. Or if you are not getting it by factorization, go with formula method. Ultimately, you will come across 2 roots which are x is equal to 1 by 3 and x is equal to
1 by 3.
So apart from doing all those things, we go with the very simple method. Right? So what is the general form or standard form of equal roots?
Minus b by 2a.
Exactly. Minus b by
2a.
You have to remember this. Right. Okay. Let us get into the third problem. Yes. Give me a quadratic equation.
Y square minus 7y
Y square minus 7y
plus 2
plus 2.
is equal to.
Right. Already it is in the standard form. Let us compare with this quadratic equation with the standard form and take out the coefficients a, b and c. Let us apply the discriminant. We will substitute the values, take out the d value, then we will decide nature of the roots through our knowledge. Right? Okay. So comparing with ax square plus bx plus c is equal to 0, which is the standard form of quadratic equation. Okay. So coefficients are okay. A is equal to
1.
y square. Coefficient is 1.
One.
So if nothing is there, it is understood that is getting multiplied by 1.
One.
Okay. So A is equal to 1. Okay. B is equal to
Minus 7.
right. C is equal to
2.
right. Plus 2 or minus 2.
Plus 2.
So discriminant is given by d is equal to b square minus
4ac.
okay. So discriminant is equal to b square. B value
Minus 7 whole square.
minus 7 whole square minus 4 into a
1.
okay into c
2.
right. So d is equal to minus 7 whole square
49.
49 minus 4 ones are 4 4 twos are
8.
okay. D is equal to
41.
oh. Let us decide. Right. D is 41. 41 is a number greater than 1 but not a.
Perfect square.
So what is your conclusion? Roots are real.
And irrational.
Exactly. Right. So since D is greater than 0 and
Not a perfect square.
not a perfect square. Not a perfect square. So therefore roots are
Real. Distinct.
Oh, nice. Distinct
And irrational.
and irrational. Right, very good. Nice. Okay, let us get to the fourth problem. Right, give me a quadratic equation.
X square plus 3x minus 4.
X square plus 3x
Minus
minus 4 is equal to 0. Yes, it is a quadratic equation with
Standard.
it is in the standard form. Okay. So comparing with ax square plus bx plus c is equal to 0. Coefficients Coefficients are, okay, tell me, A is equal to,
1.
okay, x square coefficient is 1. 1, B is equal to
3.
3.
plus 3, okay, C is equal to
Minus 4.
minus 4, right, exactly. So I'll write the discriminant. So discriminant is given by, okay, D is equal to B square minus
4
4AC. Okay, so D is equal to B square,
3 square.
okay, 3 whole square minus 4 into A,
1.
C.
Minus 4.
Oh, you have to be very careful. So D is equal to 3 square,
9.
9 minus into minus.
Plus
4 ones are 4, 4 fours are.
16.
Oh, very careful. You have to be very careful. 9 plus 16.
25.
Oh, beautiful number. D is equal to 25.
25.
So 25 is a number which is greater than 0. And what else?
Perfect square.
Yes, 25 is a
Perfect square.
exactly right. So since D is greater than 0 and a perfect square so what is your conclusion regarding the nature of roots?
The roots are
Roots are real,
Rational.
distinct
Rational.
and rational. Real, distinct and rational. Right, beautiful, good. Right, let us get into the fifth problem, very important. Right, give me a quadratic equation.
2x square minus 4x plus
2x square minus 4x
plus 3.
plus 3 is equal to 0. Okay, it is already in the standard form. So comparing with ax square plus bx plus c is equal to 0. Coefficients are, okay, a is equal to
2.
b is equal to
Minus 4.
exactly, c is equal to
3.
right, very good. So discriminant is given by d is equal to b square minus
4ac.
4ac. Let us substitute the values. So d is equal to b square,
Minus 4 whole square.
exactly, minus 4
Whole square.
minus 4 into a,
2.
okay, c,
3.
right, good. So d is equal to minus 4 whole square is
16.
minus 4 2s are 8, 8 3s are.
24.
So d is equal to 16 minus 24.
Minus 8.
Minus, minus 8. So discriminant value you have got less than 0. Less than 0. That's all. Don't tell me, sir, it is not a perfect square. Those things are not considered here. It is less than 0. That's all. Right? Okay. So if discriminant value is less than 0, then what will be the nature of the roots?
Complex or imaginary.
Or?
No real roots.
Exactly. Right. So since d is less than 0, I hope this is right. So d is less than 0. Therefore, the equation does not or do not have real roots. Right. Very good. Okay, let us now get into a different type of problem based on the discriminant of a quadratic equation. Right. Find the value of k. K is unknown. You have to find the value of k in the quadratic equation which has equal roots. So just imagine a quadratic equation ax square plus bx plus c is equal to 0. That quadratic equation already has equal roots. Already it has equal roots in the sense, what you have to think, that its discriminant value is already equal to 0. So if that is the case, then find the value of k which is being replaced by b. In place of b we have k here. So we have to find the value of this k if this quadratic equation gives you equal roots. So I will tell you the procedure how it is to be done. Okay. So now let us get into this. So take the quadratic equation 2x square plus kx plus 3 is equal to 0. Compare the quadratic equation with the standard form. Take out the values of coefficients, that is a, b and c. So comparing with ax square plus bx plus c is equal to 0. Coefficients are a is equal to ax square compared to a 2x square, a is 2, then b is equal to k, exactly, then c is equal to
3.
right. So these are the coefficients. We have a, b and c values. Now a condition is given to us, that is the roots are already equal, right? So we will write the condition. Since roots are equal, discriminant, that is d, is equal to 0. Discriminant is 0. Now what is the value of discriminant? B square minus 4ac is 0. Discriminant d is 0 means b square minus 4ac is equal to 0. Now substitute the values of a, b and c in this. Right, b square k whole square minus 4 into a
2
into c,
3
okay, 3 equal to 0. Now what is k whole square? K square minus 4 into 2, 8 3s are
24
is equal to 0. We have a pure quadratic equation. I hope you can see here it's a pure quadratic equation because the variable exists in degree 2 only, that is k exists in degree 2 only, therefore it is a
pure
pure quadratic
quadratic
equation.
equation.
Okay, so k square is equal to 24 because minus 24 when it is transposed to the RHS it is going to become plus
Plus
24.
24.
So he has asked you to find the value of k, not k square. We have k square but we want the value of k. Therefore we have to remove the square there. So the process of removing square from an equation is taking square root on both sides, which is the opposite operation. So square root of k square is equal to plus or minus square root of 24. Square and root cancels, so k is equal to plus or minus 24. Therefore k is equal to plus 24. Square root of plus 24 or k is equal to minus square root of 24. So this can also be the root value, that is k value, or if you want it you can simplify it still more, that is you can take 24 as 6 into 4 and you can take out 4 outside, that is okay, I will show you. So k is equal to square root of 24 can be written as 6 into 4 or k is equal to minus square root of 6 into 4. So k is equal to, when square root is taken for 6 and 4 is a perfect square, so square root of 4 is 2, that becomes 2 root 6, or k is equal to, the same thing happens here, that becomes minus
2 root 6.
right, alright. So this can also be the answer, this can also be the answer. So for this quadratic equation which gives you equal roots, the value of k which is being substituted in the place of b, then the b value should be, it can be either 2 root 6. If you substitute 2 root 6 in the place of k, and when you simplify this by factorization method, you can find that the roots will be equal. Or if you substitute minus 2 root 6 in the place of k and do the factorization process, then also you can see that the roots of the quadratic equation are equal, right? Okay, we will get in the second problem for the same question. Right, so these questions are being taken from the Ncert textbook for 10th standard, right? Yeah.
Kx into x minus 2
Kx into
x minus 2 plus 6
x minus 2 plus
6
is equal to 0. Okay, so this is the second question given. So we have to find the value of k if the quadratic equation has equal roots, right? But can you see this quadratic equation here? This is not in the
standard form.
Yes, exactly. You have to convert this first into the standard form. then compare with the standard form of the quadratic equation, then write the coefficients, then write the discriminant, then you have to equate the discriminant to 0 because roots are equal, right? Then we will go with the algebraic process. Okay. Right. So kx into x minus 2 plus 6 is equal to 0. Kx into x.
Kx square
Okay. Kx into minus 2.
minus 2kx
Exactly. Minus 2kx plus 6 is equal to 0. So here you can see k is in two places here. In the last problem it was a substitute of b, but in this case it is a substitute of a as well as it is a substitute of b also. Right? Right. So comparing with ax square plus bx plus c is equal to 0. Coefficients are okay. A is equal to, be careful.
K.
A is equal to k. B value, be very careful.
minus 2x
Leaving this x, what all the things you get with the sign will be the value of b. So it is minus 2k is b. Okay, minus 2k. Then c is equal to
6
okay. So since roots are equal, because he has given the condition. Since roots are equal, d is equal to 0. So what's the value of d?
0
Okay, well, instead of d, what can I write here?
b square minus 4ac
B square minus 4ac is equal to 0. Now b square, b value
minus 2k whole square
minus 2k whole square minus 4 into a value,
k
c value
6
right is equal to 0. Right. We go to the next step. Minus 2k whole square is
4k
square. Very good. So 4 into k, 4k into 6.
24k
24k is equal to 0. Right. So we'll transpose. Okay, this is again a affected quadratic equation because it is free from c. It is free from c. You can see a quadratic equation here. Here k is the variable if you consider that. Here the variable k exists in degree 2 as well as in degree 1 without constant. This quadratic equation is without constant. So how to factorize these type of quadratic equations?
By taking common.
Exactly, by taking
Common.
right? So now what do you get the common here?
4
4 and k. You are going to get common here. So 4k into k minus 6 is equal to 0. 4k into k is 4k square. 4k into minus 6 is minus 24k. Okay, now this into this is equal to 0. So therefore 4k is equal to 0 or k minus 6 will be equal to 0. So k is equal to 0 by 4. So k is equal to 0. 0 by 4 is 0 or k is equal to 6. Plus minus 6 goes to transposes to RHS. So therefore k will be equal to
6
now. Which value you are going to consider?
6
I want to consider k is equal to 0. What do you say? When I substitute the value of k here, right? 0, k is 0. 0 into x square is
0
then the quadratic equation collapses. Quadratic equation do not exist at all because this term will not be here. When I substitute 0 here again, 2 into 0 into x, this term collapses. Right? You will be left with only 6. So 6 is equal to 0. That is very absurd in mathematics. That cannot happen. Right? So k value what we have got here as 0, that value cannot be substituted here because it doesn't make the quadratic equation to exist at all. So therefore we have to consider the value of
6
k, that is another value, that is 6. So if you substitute the value of 6 here in place of k, that becomes 6x square minus 2 into 6 is 12. 6x square minus 12x plus 6 is equal to 0. Please solve it by the method of factorization or by the formula method, which is your favorite. You will 100% see that the roots of this quadratic equation will be equal. Right? Okay. Since k is equal to 0 cannot be considered, so therefore k is equal to 6. Right. So on the same basis, I am going to give you homework today. You have to do it in your classwork book and send me through the WhatsApp. So find the value of p. Find the value of p if roots of quadratic equation are equal. If roots of quadratic equation are equal. For example, first one, x square minus px plus 9 is equal to 0. Second one, 2a square plus 3a plus p is equal to 0. Third one, px square minus 12x plus 9 is equal to 0. And fourth one, 2y square minus py plus 1 is equal to 0. Right. So in this, the unknown is p here. So in the first quadratic equation, it is at b, it is at c. Here it is at a, here it is at b again. So these quadratic equations have equal roots. Then find the value of p. Instead of, in these problems we found the value of k. In these problems you will find the value of p. That's all. Same condition. So please do it and send it to the WhatsApp. Right. So until now we have covered some 5 to 6 problems. Very important on discriminant of a quadratic equation. I hope you have enjoyed the entire session. So please do these problems in the classwork and please be updated with the notes. So coming Sunday you will be writing a test on quadratic equations. So until that, stay home, stay safe and keep learning. Thank you.